So, starting a third problem. We'll put a little more pizzazz in your lives. Okay, so you'll notice your interval is a little unique. One end is a parenthesis, one end is a bracket. So the bracket could actually be an answer. The 4 could be an answer. Do I have to do any limits or not? If you have a parenthesis, you do a limit. So we have to do a limit approaching -1, because -1, it can't be an actual answer, but we still have to know where is that endpoint at. How high is it? And, yeah, when you sub that into your limit, oh, it's not 0, you're right. It's going to be -2 to the 2/3 power, which is really what? Because if I put that in there, that's really saying that's -2 squared. So that's really a positive cube root of 4. Just suppose I have that decimal. Nope, I don't. Okay, well, I guess we'll look at this. Okay, so realize how does that impact our decision about our absolute maximums and minimums? For there to be an absolute maximum, we have to get a point that's higher than the cube root of 4. For us to have an absolute minimum, we have to get something that's lower than the cube root of 4. So it kind of matters. So that was at -1. Cube root of 4 is 1 point something. 58, thank you. So we know that at that point the graph is there. It could go higher than that, it could go lower than that, because this graph could bounce around, who knows what all it does. So we just have to be aware that we have to get points higher or lower than that to have absolute maximums and minimums. So we'll think about it at the end. Otherwise, what do I need to do? Find the critical points, yep. Which means chain rule, yeah, baby. Times the derivative inside. Thank you. Got my power, thank you. Times 3x squared. 3's will cancel. Since that's a negative power, I'm going to drop it to the bottom. If you want to leave it as a 1/3, you want to put it in a cube root. I think you all see it better when you put it in roots, but okay, so that's what I'm trying to set equal to 0 and solve. So, oh, whoa, x-3 minus 1, thank you. Okay, I get what you're telling me. So no, Alex says I'm just doing 2x squared equals 0. Is he right? Because when you want a fraction equal to 0, it's really only the numerator. If I multiply this over here, the denominator will become 0. So yeah, if I set 2x squared equal to 0, I'm going to get 0. Oh, the other thing I didn't say to you, where you have a very restricted interval like this, you need to make sure that your critical points are within that interval. If you get a critical point that's not between -1 and 4, you don't use it. Because you only want answers between -1 and 4. So, this one's good though. Alright. Is there anything else here anybody's going on?
Both. The one it started out without a rational number.
We started out with no fraction, no denominator. Now we have a denominator. Remember the special critical points, the points of non-differentiability. Is there a number that makes this undefined down here in the derivative? 1 would make that undefined. Would 1 have been a legitimate value in the original problem? 1 minus 1 would have been 0 to the 2/3, which is 0. That's a good number. So, then yes, 1 is also a critical point in this situation. You see those fraction powers? That's like screaming at you. I'm going to get those special critical points. Happens most of the time with them. So we need to check 0 and 1. I check it how? Put them in the C table. Any other numbers I need to test? 4, because it was bracketed. Okay. So, if I put 0 up here, I'm going to have negative 1 to the 2/3 power. Since that's a 2, realize you're squaring it. Cube root of 1, which is just 1. If I put 1 in there, 0. And if I put 4 in there, so that'd be 63 to the 2/3 power. I guess 1, that would probably be good. Thank you. It's approximately 15.83. That's looking pretty maximum. But, what do I have to remember to look at when I'm deciding which is the maximum and the minimum? That cube root of 4. We got to come in higher than it was about 1.58. So it's got to be an absolute maximum. It has to be something that was higher than that. Yes. So, or they will probably have written, I think they just write it as 63 to the 2/3 or 15.83, but I think they actually just leave it like that. I don't care indicate with any version of that. Okay, did I have a minimum? Did I have something come in lower than 1.58? 1, 0. So, I successfully mastered that. Oh, by the way, you should look for all your answers on this assignment or on the back of the assignment sheets. The way the book wrote the answers was just wacky weird. So, I put them all back there. They didn't list them as court, and they do strange notation stuff with it. Okay, one last one. We're having fun now. You need a little fraction action in your lives. Okay, 0 to infinity, both parentheses. What do? Limit land. But realize most of these limits, they aren't going to be super complicated. Most of them are going to work by just subbing numbers in. This isn't going to be, usually these kind of limits aren't that elaborate. I put 0 in there. 0 over 1 is 0. That's not so bad. Okay, this is an infinity one. It's actually going to be infinity or infinity. We can do L'Hopital's rule, or we can take highest power out of top and bottom. What floats on both? Highest power terms, okay, which would be x over x squared, which is going to reduce to 1 over x, which is then when I do 1 over infinity. So both endpoints go to 0. So therefore, for us to have an absolute maximum, what's going to have to be true? It's got to be something that's bigger than 0, and to have an absolute minimum, it's got to be something below 0. Okay, so what's going to make this a fun one? Derivative quotient rule. But after the ones you were doing earlier, this one doesn't look that bad. So, low, D high, high, D low, and then, of course, need to clean it up, which actually this turns out kind of nice because that's minus 2x squared. So I can combine like terms and have what? Okay, so do you want it negative x squared plus 1 or 1 minus x squared? I heard 1 minus x squared. Others of you may have heard it, said it, but that's the one I actually heard. Okay, gotta solve this puppy. What am I solving? Yeah, 1 minus x squared equals 0. Ooh, it's a toughie. I get plus or minus 1. Do I have to worry about the special critical points? Yeah. You started with a fraction, started with x squared plus 1. You got the same quantity at the bottom. No, plus x squared plus 1. Instead you got something squared plus a number, you can't make it equal 0 anyhow. It'll be imaginary. So I'm going to have to worry about it. So do I just have 2 critical points to test? We got negative 1 and positive 1. How am I testing them? I'm doing a t-table. There's something you need to notice. Yeah. Are they both in the interval? Nope. Negative 1 is not in the interval, so we can't use it. So we just have 1 to test. Okay, I think we can handle that one. 1 over 2. Woo, doggies. Yeah. So, is it an anything? It's a maximum. Why is it a maximum? It's above the limits of 0. It's higher than that. So yes, it's a maximum. So what about an absolute minimum? There is none, yeah. We just don't have one in this particular case. Would it ever be possible to get like 2 absolute maximums?
If they were the same, y,
Yes. If they had the same y coordinate, they were at the exact same height, you could get 2 of something. I won't say.
But it was funky.
I mean, it's not going to be a real common occurrence, but it could happen where you had. Yeah, true. It was a sine wave or something like that. That was where you get the same point several times. So that was good. That was fun. Key thing is, think about what these limits are telling you. They aren't just there for fluff because I said you had to do them. That's always what causes problems. Okay.